Welcome back. My apologies. I started a live stream, an old live stream. That's my fault, and I apologize for that. So this is live stream 55, the 55th episode in our space shooter DevVenture. Okay, so I've opened up Krita here to do a quick recap on the flea behavior before we actually go ahead and improve on what we've done from our last session. So there's this, what do we call this? The deflection angle band, or the deflection angle range, the flea angle range, and the return angle range, right? So that is a range of 30 degrees, right? So not radians, degrees. And that would be 90 tangential to the radius, whichever radius we're talking about, right? And so you hit the circle and you go tangential to it, or greater by 30 degrees. So this line is actually incorrect. It should be, that's the tangent, and it should be 30 degrees this way. So I should actually fix that. Let me do that. We'll fix it quickly, and then we'll go back into Perplexity and do the remaining work for flea behavior, right? So I want to make an angle here like this. Oh, right, oops, that's eraser, this is pen. I see that's 5 pixels. We can change that to 2 pixels, like that. Okay, switch back to a pen, and then $30 degrees. So that's the return angle range, right? And then the next thing we can focus on here, so I'm just going to switch back to my cursor so you can see where I'm pointing, right? So that's the the danger radius. Excuse me. And then this is the safety radius. And we want the enemy ship, or the AI actor, to reach the danger radius, perform a deflection or flee, right? Go towards the safety radius, and then call complete, at which point it then moves on to another behavior, right? And so what we want to do is get to this point. Okay, so we found out that at the end of the last session, the ship was doing this kind of like zigzagging behavior. When it hit the danger radius, it kind of did a zigzagging behavior and just carried on going straight. That's not exactly what we wanted, and I think I know why. Okay, so let me open up. So this is Perplexity. That's fine. Before we talk to Perplexity about this bug and why it's not behaving the way it should, right? I want to do a quick test in Godot engine and make sure that my theory is correct. Okay, now we know for a fact that in testing seek behavior, if I go to flee, we've got these two radii, right? Radii, plural. So we've got the danger radius and the safety radius. And we know for a fact that these are way too big. Okay, because the testing seek behavior environment is so tiny, I don't even think all the waypoints fit within a sphere of radius 80. So let's do something way smaller. Something like the danger radius is 10, the safety radius is 20. Okay? and we can save that. And now we can go back and test it. Okay, so if I do this, watch now. If I do this, it's going to pause, arrive, shoot 5 shots, call flee, still doing a zigzag behavior, which is weird. So let's fix that now. Okay, now we know it's not because the radii are incorrect. Unless we make it even smaller, right? We can make the danger radius 5 and the safety radius 40. So now there's a big gap that it has to flee through before it counts as a successful flee, right? Let's try that. Okay. So it comes and parks, and then it shoots 1, 2, 3, 4, and 5. Still does a zigzagging behavior, and then it hits the waypoint, and the other behaviors kick in, right? Like reached waypoint, find a new waypoint, carry on doing its thing. So there's something fundamentally wrong with our flee behavior, which is good. Now we know, right? Now we know it's not just a mistake in the radii of our code. So I'm going to copy all of this. I'm going to take it into Perplexity and paste it. Actually, no. I'm going to say a message first. So here is the code for behavior flee.gd. Paste that all there. There is a weird zigzagging behavior with the AI actor once the flee behavior kicks in. I tried changing the danger radius and the safety radius, but the zigzagging persisted. That means there is a semantics error in the code somewhere, and I need your help to find it. Okay, so let's see what it's saying. The zigzagging comes from recomputing a new random deflection direction every frame. So the ship keeps changing its flee heading slightly each process call. The movement is correct, but noisy. Just give me 1 second, I'm trying to sort something out here. Okay, I've sorted it out. Now we can carry on reading this message. So in process, you compute direct flee direction each frame. And then you call compute deflected flee direction also each frame. So this picks a new random angle between 90 and 120 degrees every single time. So even though the ship is always moving somewhere away from danger, the heading jitters randomly frame to frame, which reads as a zigzagging. So the simple fix: choose one direction per activation and then interpolate. Yes, Exactly. The easiest semantic fix: compute the deflection angle in the activate and store it, and then in process use that stored flee direction every frame instead of re-randomizing. Perfect. Concrete change: add a stored direction at the top, and then in activate, after you resolve danger position and pass the so-called has danger checks, compute and store the flee direction. Then simplify the process function to use the cached direction, and leave compute directed flee direction unchanged. It is now only called once per activation. This keeps your 90 degrees to 120 degree deflection band or deflection range, but it removes the jitter because the random choice is made once at the start and not every frame. Perfect. So I'm going to move this to the side and we'll get started with that. Okay, so we'll open up Godot Engine. And start at the top, right? So at the very top of this file, we want to add a variable called flee direction cached. So we'll put it down here. Variable flee direction underscore cached. This is of type vector 3. And the answer is a vector 3 dot 0. Okay, so that's it. And then that's there. And then in the activate function, we have to go down to if not has danger position over here, then push an error behavior completed.emit, and is active is false, call return. Then before you print this flee behavior message, we add in some code below it. So we add code in here, right? We say all of this here like this. Okay. So ship position, the to danger, if to danger dot length is greater than 0, deflection direct flee direction is negative to danger dot normalized, flee direction cached, compute deflected flee direction, direct flee direction. And then flee direction cached is negative enemy ship.global transform.basis.z.normalized. That's a lot of dots. But yeah, so it's literally just going forward, but using the negative because in Godot Engine, negative Z means forward. Okay. And then normalized is literally just to get a direction and not a magnitude of a vector. So that's the end of that. Flee behavior activated for ship enemy ship ID from danger at danger position. There's extra print message information. We'll add that in. There you go. Okay. Go back to the top of this section here. Yes, that's fine. And then we go into the process function and add some modifications there as well. So in the process function, if not is active or not enemy ship, call return. If danger node and is instance valid, danger node, then danger position is danger node global position. Ship position, vector 3, enemy ship global transform dot origin. To danger, vector 3, danger position minus ship position. The distance, which is a float, to danger length. All of that's fine so far. So where's the difference? If we are already safely away, then complete. If the distance is greater than or equal to the safety radius, then do the completion code. And if we are still outside the danger radius, but not yet outside the safety radius, you can either drift or keep mild flee for now. Always flee from flee when between danger radius and safety. If distance is less than or equal to 0, then return, then direct flee direction. Okay, so this is the old code. Let's see now. If the distance is greater than or equal to the safety radius, oh, never mind. We had that already. So we literally just have to take out these 2 lines of code. Something like this, right? And then we add a comment here saying, use the cached flee direction no per frame random jitter. Okay, and it should be flee direction cached. So that's the end of that. And that should fix it, hopefully. We'll save this and test it. Okay, we'll call the test attack pattern. It's gonna park, shoot 5 bullets. 1, 2, 3, 4, 5. Flee behavior activated for ship 0 from danger at 30 with flee direction this. Ship 0 is ready for next pattern. So it looks like it was already outside the safety radius. Let's go back to flee. Check that the safety radius is 40. Let's make that 80 again. And try again. Okay. Okay, let's try this. We'll copy the output, put it into Perplexity. I tested the modifications. Here is the output from the last run. Here is the code from behaviorflee.gd. Why is the AI actor not fleeing as expected? It merely remains where it stopped during the arrival phase of the pattern. In process, you have this. Since distance is always greater than or equal to 0, the second if always returns. So apply flee motion is never called. The ship just stays where arrival left it. The fix, if you want to only early return when distance is invalid for now, you also want to flee whenever distance is between 0 and the safety radius. So change that block to this instead. And then that is the only change needed in the process function for the current design. After this change, when flee activates, it will use flee direction cached to move the ship away each time each frame until distance is greater than or equal to the safety radius, and then complete and let the pattern finish as expected. Okay, I understand. I think. Right, so what I want to do here is I want to move this over to the side and then go into the process function, and where it says if distance is greater than or equal to the safety radius, so switch that to less than or equal to 0. If it's greater than or equal to the safety radius, call behavior completed, and why is this so unorganized? Disorganized. Yeah, okay. So that sign was, that inequality was switched around. Let's test it. Okay, spacebar, let it go, watch it come to its stop, shoot 5 shots, 1, 2, 3, 4, and 5, then off it goes with a random deflection angle till it reaches a safe point, which is about 80 units away from target at the current setting. And there it goes. Attack pattern completed sequence. Ship 0 is ready for next pattern. Okay, so that's good. Now we can go back to flee, change the safety radius back to something reasonable, like, I don't know, 20, and the danger radius to 10. We can test it one more time, and then carry on with our improvements, right? So it's going to do its job. Yeah, there you go. So now we have the right flee behavior logic. We need to improve on this, and we also need to add mining objects into testing seek behavior instead of just waypoints, so that the enemy ship knows to avoid them. So if it's going towards this waypoint and there's a mining object in the way, it has to avoid it on its way, right? And that's the desired behavior. And that should be working no matter what pattern happens to be running. And yes, it is about as complicated as it sounds, and probably a little bit more too, right? And I am not very comfortable thinking about that. It's a bit daunting, but we have to do it, right? We have to do it. That's the behavior we want, and so that's the work we have to put in to get it done. Okay? We'll just do it step by step. We'll just take it small steps at a time. That's how you do it. You just break it down. You take it one step at a time. Thank you. Thank you for the help. That fixed it. Now let's focus on the next step / iteration of this behavior. I remember we talked about making the AI actor avoid non-target collision objects while actively following the current behavior pattern. For example, if the attack pattern, we'll switch this to a small if the attack pattern is running and the AI actor encounters the danger radius of a non-destructible collision object like an asteroid for the pirate or a target for the mining vessel, then the flee behavior should kick in without eliminating the attack pattern. This seems complicated to me, but pattern persistence in the face of a temporary interruption will make the AI actors more robust and better to play with for the players. What do you think? Are there more fundamental steps to take before this edition? The idea is solid and it is the right next layer of sophistication, but it needs one structural step first. A way to run flee as a temporary override rather than as a normal pattern step. Why this needs an extra layer? So right now, a pattern is a linear sequence: arrival, shoot, and flee. The NPC behavior manager always runs exactly one behavior at a time, in order until the pattern completes or the pattern is interrupted by a new pattern assigned. Right? If you simply kick in flee from a collision event by assigning a flee pattern, you will interrupt and clear the clear the current pattern, losing your place in arrival, shoot, and flee. After flee completes, the manager has no memory of what behavior it was running before. To get avoid obstacle but resume attack, you need behavior level overrides or a small stack of pattern behavior states. Right? So one foundational step to add first is that before wiring obstacle detection, we need to add a minimal interrupt and resume mechanism inside NPC Behavior Manager. Yes, that makes sense. Right? So there needs to be a difference between pattern or other behavior cancelled and behavior interrupted. There needs to be that distinction. And that distinction happens in the tactical layer. So if I go back to Krita for a second and I open Just give me one moment. I'll be there soon, I promise. There we go. Right. So we are currently talking about the NPC behavior manager, which is over here in the tactical layer, right? Now flee happens down here in the operational layer. So if we want to do a cancel, if we want to do a cancel, right, that means we call so we send a report up to the tactical layer saying the behavior was cancelled, right? So we, for whatever reason, flee was, or rather arrival or shoot or flee, whatever the part of the pattern was supposed to happen, was cancelled because there was a there was whatever reason, right? There was, for whatever reason, the behavior was cancelled. In that case, we call cancel, right? And then the tactical layer says, okay, well, if it was cancelled, then we need to decide, right? Is the entire pattern cancelled or just that behavior? Do we continue with the remainder of the pattern? So if we were mid-pattern and the behavior comes back as cancelled, we need to make a decision and say, okay, well, for this particular pattern, it doesn't matter that this behavior cancelled. We can continue with the pattern. So do the next part of the pattern. Move on from using the attack pattern. Let's say arrival was cancelled. Can you still shoot? Yes? Okay, shoot. Right? Otherwise, it's like, well, can you still shoot? No, because we never arrived. We weren't close enough. We didn't get close, within firing range or whatever. And so now we can't continue. And then it's like, okay, well, then cancel the pattern. And so it sends another report to the strategic layer saying the entire pattern is cancelled, awaiting next pattern, right? But then there's also a difference between cancel and interrupted, right? So we can send a report to the tactical layer saying the behavior was interrupted. And instead of calling pattern cancelled, we can say pattern paused. You see? And we can keep that pattern paused and start a new pattern, right? We can call it secondary pattern or temporary pattern or whatever. Run that pattern and then resume the old pattern. Do you see the difference? Right? And that's basically what Perplexity is talking about. So if we go back here, that's what it's talking about. We need to have a way to pause the current pattern and make room for the new pattern so that it can run its course. And when it's done, we resume the old pattern and it can run its course. And then once it's done, we can request another pattern from the strategic layer. Okay, so that's the fundamental addition, this foundational step that we need to add in, right? Before wiring the obstacle detection, we need to add a minimal interrupt and resume mechanism inside the NPC behavior manager. So we need to allow temporary behavior overrides that save the current behavior and the sequence index, then activate the flee. When flee completes, restore the previous behavior and let it continue. Example, resume shoot. Okay, structurally, this can be as simple as extra state fields in the manager. So like override behavior is a node called null. Of type node is null, and then save behavior of type node is null. Save sequence index int 0, and then int override bool is false. And then we have a method like start override behavior flee parameters that stores the saved behavior and the saved sequence index, sets in override to be true, so we know that we are currently in override mode, and then activates the flee behavior directly without changing the current pattern or the current sequence. So on behavior completed, if in override is true and behavior type is flee, restore current behavior equals saved behavior, and restore sequence index is saved sequence index. Right? So the old behavior we were doing, the old pattern was attack, and we were at index 2 in attack pattern, for example, right? Or we were in index 0. We were still trying to arrive at the location for shooting, but we hit an emergency flee point, right? And I can see a problem with this architecture when there's a breaking case in this whole pattern when we need to avoid multiple asteroids, right? And we'll have to advance the flee behavior accordingly. So if there's a collision object and we reach the danger radius of that collision object and we try to avoid it, and while avoiding it we hit the danger radius of another collision object, do you see now how that's going to override the original flee, start a new flee, and we suddenly lost the paused pattern? And this could happen n times, right? So it could hit asteroid 0, asteroid 1, asteroid 2, asteroid 3, asteroid all the way up to asteroid 1000. And it finally avoids all of the asteroids, and then it goes, okay, now where was I? And it's forgotten, right? So there's going to have to be some kind of pathfinding algorithm in flee. We'll need to add that into flee as a behavior so that it doesn't keep reassigning flee every time. Otherwise, we make the safety radius really close to the danger radius. So it's a tiny little margin. So it goes like 5 to 10 or 5 to 7, really small. And that will hopefully prevent this asteroid stacking, or whatever you want to call it, flee stacking. I think that would probably be a simpler solution. Ideally, you would want to have that sophistication put in place so that it's like, I want to flee from this asteroid and I need to travel this particular distance away from it. So when I do, and I have that heading, are there any asteroids in that direction? Because remember, that band of angle isn't just in one direction. It's a 360 degree circle, right? It's a volume, it's not a surface. And so I can rotate my ship to face any direction and then turn according to that band and go, right? And so I can figure out where the asteroid is and not go towards it and then shoot away in some direction. So there's that. And that's another layer of sophistication we need to add to flee. But we can do this part first, right? I need to write this down before I forget it. There are some other additional sophistications we must add to the flee behavior, to behavior flee, before we continue with the or not before we continue, but as we continue with the interruption or the pattern interruption logic. There is a real possibility that the AI actor could reach a non-destructible, non-destructible collision object, forcing it to interrupt the current pattern and flee. This is known, and we are currently working to address it. There is also an edge case, however, where the AI actor deflects from the current path during flee and heads towards another, we'll say this, another non-destructible collision object, right? Just trying to think about my words. Yes, okay. This could repeat n times or indefinitely if we are unlucky. And I'm concerned that the suggested implementation will not be able to support a successful resume operation in such a case. I have two ideas to solve this problem. A simple one and a more robust but also more complex one. Simple: reduce the gap between danger and safety radii. Complex and robust: make the deflection volumetric, i.e. a three-dimensional rotation, and check the trajectory for other collision objects, adjust angle until the path is clear. What do you think about this? I haven't implemented the points you made in your last response. So you can integrate this idea into that response and show me the new and improved version before I implement it. Okay? The concern is valid. Without care, Flea could bounce from one obstacle to another and never let the main pattern resume. Your two ideas, narrowing the danger safety gap helps, but it only reduces the distance of each dodge. It does not prevent dodge into another obstacle if the space is cluttered. A fully volumetric deflection with trajectory scanning is robust but heavy. You would need to sample or raycast candidate Flea directions and pick the one with least collision risk, which is essentially context-based steering or obstacle avoidance steering. For your current architecture and milestone, a middle path is better. Keep Flea simple and let your override mechanism handle repeated interruptions gracefully. If NPC Behavior Manager gets the ability to run Flea as an override behavior, not as a pattern step, you can make the system robust against repeated dangers. So the manager saves, saved pattern, saved sequence index, saved behavior, or just enough to start or just enough to restart the current behavior pattern or behavior. Then when a non-destructible danger is detected, if not already in override, start Flea with override with danger position for the nearest obstacle. And then when a Flea completes, if still in danger, the sensor can trigger another override, but the main pattern state is still preserved. If space is clear, the manager resumes the saved pattern or behavior. This way you do not rely on Flea getting it perfect in one move, and multiple Flea overrides are allowed, but they never erase the pattern context. They just temporarily take control of steering. Given that strategy, Flea itself can remain relatively simple. Use a reasonable danger radius and safety radius, tuned so the ship doesn't overcorrect, and then a cached deflected Flea direction per activation, which you already do. Optionally, add a max duration or max distance failsafe after n seconds or m units traveled. If it's still not safe, then emit the behavior completed, failed, reason, Flea timeout. And then the manager can decide whether to try another Flea or escalate, like pick a different pattern. You don't need full volumetric trajectory scanning yet. Instead, you can rely on the Flea's single deflection with moderate randomness, the override mechanism to allow multiple short Flea episodes when needed without losing the main pattern's place, and the recommended next step, updated, is that before working on multiple obstacle avoidance inside Flea, implement the override lane in the NPC Behavior Manager and add fields like those suggested, and then add the start override behavior function. In override, ignore already handling one. If we already are in override, then ignore, because we're already handling one, and then save the current pattern state and behavior, set in override to true, activate the override behavior flee by looking it up in available behaviors, but without changing current pattern or sequence. And then on behavior completed, if in override and behavior type is flee, then set in override to false and then restore the same pattern. So resume, call the resume behaviors. Restore the pattern behavior as appropriate, and either reactivate the previous behavior or let the next frame of that behavior pick up if it wasn't fully deactivated. Once the override is in place, wire a simple danger detection that when the ship is within some radius of a non-destructible collider and the current pattern is something that like attack, then it calls start override behavior flee danger position equals this. And then only after that we revisit flee's internals if testing shows lots of repeated collisions. So narrow the radii to reduce overrun. If needed, add a simple directional bias instead of a full volumetric search. Prefer deflection towards open space based on a couple of raycasts instead of a full volumetric search. We were never going to do a full volumetric search. It would rather have been something like get all the nearby asteroids within a specific radius and calculate the vectors towards them and then choose an angle that isn't one of those. But okay, whatever. This keeps flee logically simple and pushes robustness into the manager, which is where pattern persistence belongs. Okay? So you are saying the new implementation will allow the AI actor to interrupt the current pattern and flee while preserving the current pattern on the resume. But it can also interrupt the temporary flee but also override the temporary flee with a new flee if it hits a new danger radius during the flee operation. Does my question make sense? Yes, that is exactly what the override approach is meant to support. With an override mechanism in the NPC behavior manager, when a non-destructible danger is detected, the manager saves the current state without clearing it. It then starts flee as an override behavior, steering the ship away from the immediate danger. While flee is running, if another danger appears, the sensor can trigger another flee override, either by restarting the same flee behavior with the new danger position or by updating flee's parameters if you decide to support that. In all cases, the saved pattern behavior context is left intact, so the main pattern is still waiting in the background. And then when flee finishes, the manager marks the override as done and resumes the saved pattern, either by reactivating the interrupted behavior or moving to the next step, depending on your design. So yes, the AI actor can temporarily leave the attack pattern to dodge, then resume it where it left off. And also, yes, if another danger appears during the dodge, you can override the current flee with a new flee and still preserve the attack pattern for later resumption. And this can happen as many times as required, and it will still resume the saved pattern when it finishes, or when it finally reaches safety. Yes, as long as the override mechanism is designed correctly, it can happen many times and still resume the save pattern once safety is finally reached. How repeated overrides still resume correctly? With the override lane, the main pattern state is saved only once when the first override begins. While in override is true, new dangers can trigger updates or restarts of the flea behavior, but they do not touch the saved main pattern state. And you don't override anything. They remain. You don't overwrite save pattern or save sequence index again. They remain the original interrupted context. And then when flea finally completes successfully, the manager sets in override to be false and restores the save pattern or behavior context and resumes it. So regardless of how many times flea is restarted or reparameterized while in override is true, there is still a single saved pattern state to go back to once the avoidance phase is over. And that's exactly what I was trying to establish, that this is a real risk. We need to have that in mind, and it seems like we're taking that into account now, so I'm happy with that. We've kind of reached the end of our, of the hour. We have about 3 minutes left, so I'm going to do the housekeeping now, right? So thank you so much to Cubes for your support. He's our junior DevVenturer. That's a membership tier in my Ko-fi page. You are welcome to go and check out the Ko-fi page. The link is here at the bottom and also in the description. And then a reminder that you are welcome to join the Discord community. The link is also in the description. It's extended to anyone who has the link for, forever. So do join the Discord community, and you're welcome to join, have discussions. There's all kinds of different channels for you to talk about game development and all kinds of other things. You'll see it all there. And then you are welcome to check out the Ko-fi page and see the different membership tiers and the perks that are listed on that page. If you don't want to become a membership just yet, you can also do one-time donations. And thank you very much if you do. And then for the remainder of this time, I'm going to just remind you to like, subscribe, and share, and promote the channel as much as you can. Your support is very much appreciated. And yeah, so for just moving my portrait around. Yeah, so I think that's everything. When you like the video or you share the link with others, you are signaling to YouTube that you like my content and that my content is valuable, right? And that allows YouTube or gives YouTube the go-ahead to promote my content to others, right? And obviously that improves the channel. And so the channel growth on its own is also a very, very important thing in terms of supporting the growth of DevVenture with MTK. So however you decide to support the channel, I appreciate it very much. And thank you so much. But yeah, we've kind of reached the end of the hour now, so I'm going to close off here. Thank you so much for your time and your attention. and I'll see you in the next live stream.